So say that you had a language with functions that took in numeric constants that represented different states. For example, in the case of this align horizontal function, it took in a number which represented things like left, center, and right. The first problem is that code like this isn't very readable. For example, if I remove this comment and I'm just looking at a line of code that looks like this, I have to have knowledge in my head that says that 1 represents a value of left. There's nothing in the code that tells me what this 1 represents. I have to know it. The second problem is that a system like this allows the programmer to create errors that could be solved through some sort of static program analysis, like type checking. For example, here the programmer is allowed to type in a value of 4, but this will cause an error when they go to run this code. The thing is that we know that 4 isn't a valid value, so really they shouldn't be allowed to type it in at all. An intuitive solution to a set of problems like the above is something like a Java enum, which creates a type that allows you to wrap a set of values, like these ones here, and alias them with more readable names. Enums also have the advantage of adding abstraction to your language, meaning when I'm looking at a chunk of code like this, I don't have to know the underlying value of something like left, center, right. That information has been abstracted away. So what we would like to do is modify our language so that developers can use these new enum-like blocks instead of these old numeric constants. So in an ideal world, we'd like everything to act completely abstractly, just like Java enums. For example, this align horizontal function would only be able to take in horizontal alignments, and this align vertical function would only be able to take in vertical alignments. You wouldn't be able to pass the other kind of value to the other kind of function. And we would only be able to compare things that return horizontal alignments against other things that return horizontal alignments. You wouldn't be able to compare them against vertical alignments, for example. So essentially, in our ideal world, everything is abstract. The setters, the getters, and the enums themselves. But as I mentioned, right now we're not building a completely new language. We're actually making an extension to an existing language, which means that we have to deal with backwards compatibility. So as I mentioned before, in the past developers would use these numeric constants to represent different states. So in most cases, we can do an automatic upgrade from the former to the newer by doing analysis of the developer's program. For example, every time we see a value of 1, it will create an enum to replace it. But this isn't possible in all cases. For example, in the past, people were allowed to assign expressions to these setter functions, and there's no way for us to do an automatic upgrade of an expression like this to an enum. So this is our main backwards compatibility constraint. We need to make sure that expressions like this continue to work in the same way they did in earlier versions of our language, which means that this function must be able to accept numeric values. And that in turn it means that this value must be able to act as a numeric value because our language here has no concept of overloading. So most of the problems in our language can be solved this way, by allowing our abstract enum-like values to act as numeric values under certain situations. For example, here are some things that were possible to create in the previous version of our language. So we need to make sure that they continue working in the same way in the new version of our language. So in the past, it was possible to connect this align vertical getter to this align horizontal function. So we need to make sure that this value can act as a numeric value in the future version of our language. It was also possible to wrap this align vertical getter in an expression before passing it to the align horizontal function. So we need to make sure that this value also works as a numeric value. And lastly, it was possible to compare your align horizontal getters with your align vertical getters. So we need to make sure that both of these values can act as numeric values and are acting as numeric values before they are compared. But where these things get really interesting and complicated is when we see how these new enum-like values will interact with dictionaries. So in the past, it was possible to create a dictionary with numeric keys and then access it using an align horizontal getter to get the values. So for this to be backwards compatible, we need to make sure that this value acts like a number when it's doing the lookup. But once we add these new enum-like values, it makes sense that a developer might also want to use those as keys in the dictionary and access them using the align horizontal getter. So if we want to be completely backwards compatible, meaning allow this situation to work, and completely forwards compatible, meaning allow this situation to work, we actually need to do a two-stage lookup of our dictionary if we're dealing with this enum-like value. So first we do a lookup of the abstract value so that we can find values in dictionaries whose keys are the enum-like values, for example here. And then if we don't find anything, we do a lookup of the underlying numeric value so that we can find values in dictionaries where the keys are numeric. So in summary, programming language design is tricky, especially when you're trying to extend an existing language with additional functionality. And especially when that additional functionality takes a very concrete system and tries to make it more abstract.